lecture 9 and the topic of this lecture is Zener Diode. What is Zener Diode? A Zener Diode is a silicon p-n junction device that is designed for operation in the reverse breakdown region. So when a diode reaches reverse breakdown, its voltage remains almost constant even the current changes. So this is the key to the Zener Diode operation. So that is the main reason the Zener Diode is used for the voltage regulation. So instead of straight line representation the cathode, the Zener Diode has a bent line. So this is a bent line. So the bent line is a cathode. So that reminds you the letter Z. The anode is the same for the diode. This is the anode terminal and this is the cathode terminal. So the Zener Diode is operate in the reverse breakdown region. So Zener Diode are designed to operate in the reverse breakdown region. So two types of reverse breakdown in a Zener, avalanche and Zener. So the avalanche effect occurs in the both rectifier and Zener Diode at sufficiently high reverse voltages. Zener breakdown occurs in the Zener Diode at the low reverse voltages. A Zener Diode is heavily doped to reduce the breakdown voltage. This is called a very thin depletion region. So in this figure you can see this is a forward bias direction curve, and this curve is same as the diode. But in the reverse bias direction, this is a VZ and this is a breakdown region, also called the Zener breakdown. So this Zener breakdown occurs in a Zener Diode at low reverse voltages. So these are the x-axis VF and this is the negative x-axis VR, IF also same the diode, and IR actually it is in microampere and IF in milliampere. So these are the voltages. Breakdown characteristics of the Zener Diode. So the reverse voltage VR is increased, the reverse current IR remain extremely small up to the knee of the curve. So in this figure you can see three different points of the curve. The first is IZK, the second is IZ test current, and the third is IZM. So let us discuss what is IZK. Actually IZK is the Zener knee current. And what is Zener knee current? So the Zener knee current is the minimum value of the Zener reverse current required to maintain the voltage regulation. So this is the point of VZ and this is the point of the voltage regulation. The change in current is very high, but the change in the voltage is very small. So this is the main property of the Zener Diode. The next one is IZ test current. So the IZ test current is the value of the Zener Diode at which the normal value of the component are measured. So this is the main working region of the Zener Diode, IZ kit. And the third is IZM, the maximum allowable value of the Zener reverse current. So this is the maximum allowable value of the Zener current. So at the point the breakdown effect began, the internal Zener resistance, also called Zener impedance ZZ, began to decrease and the reverse current increased rapidly. So actually we will discuss what is ZZ in our next slide, Zener equivalent circuit. So there are two types of Zener equivalent circuits, the ideal model and the practical model. So the ideal model, we change simply a battery of VZ. So VZ actually the regulation voltages. So this is a point VZ where the Zener breakdown occurs. It has a constant voltage drop equal to the nominal Zener voltages. So this constant voltage drop across the Zener diode produced by the reverse breakdown is represented by a DC voltage. But in the practical diode model, This is the second approximation of the Zener diode. This diode is replaced with the VZ, and this is a ZZ that we have discussed in our previous slide, Zener impedance. So VZ in the series of ZZ, and this is the practical diode model. So in this figure you can see this is the point of the IZK there. So IZK actually the Zener current, and this is our working region. In our working region we consider ZZ, and we add ZZ in our calculation. So this is the second point, and this is the Zener test current point, and this is the Zener maximum allowable current. And you can see the voltage change is very small, but the current change in current is very high. So this is the overall characteristic of the Zener diode.